All right, we're back. We're on page 2, notes 19. We're talking about motion, so like velocity, acceleration, position, and antiderivatives. So the integral of acceleration is velocity, the integral of velocity is position. We'll use the candidates test sometimes. We'll use accumulation functions to just write things, like a lot of good stuff, a lot of my favorite things that we get to do. So this is a calculator problem. That's good. A particle moves along a straight line. For 0 to 3, the velocity is given. It's 2 plus 1/5, the quantity, t cubed minus 4t to the 5/3 minus t squared. And the position is given by s of t. We also know that s of 0 is 3. So a lot of information there. Definitely going to define v of t on the calculator. All right, so find all values of t between 0 and 3 for which the speed of the particle is 1. All right, so before we go to the calculator, speed is the absolute value of velocity. So we need the absolute value of v of t to equal 1. There's actually 2 ways that we can deal with this on the calculator. So we're just going to get values. One way is to graph. Well, you can try solve. I'm a little afraid. So the reason I'm afraid is that sometimes these problems like kill your calculator. When your calculator is just spinning, right? You get the spinning clock of doom or whatever. Hold escape until eventually it will say break or operation broken or something like that. The problem is that doesn't work on the computer. So if I try to do something that doesn't work, the calculator is just going to freeze up, and then we're going to have to wait for it to restart. And I probably should have tried this before making the video, but I didn't. So here we go. I'm going to define v of t. You know what I'll do? I'm going to do it in a weird order. I'm going to do like, why would I define it as answer? 2 plus 1/5 t cubed minus 4t. I wonder what my fingers were trying to do there when they typed answer. like I definitely had to type that. And my brain was not consciously doing it. Okay, so this is our thing. All right, one option is I could try to solve the absolute value of v of t equals 1. See what happens. Another option is if I really want to use solve, which apparently I do, I can solve v of t equals 1 for t and just get values of t. Okay, so I got 2 of them between 0 and 3. Then I'll solve when the v of t equals -1, right? Because if the absolute value equals 1, then either v of t equals 1 or v of t equals -1. So let's get that. So it's actually, there are 4 values. So I'm going to jot these down. So t, 3 decimals, 0.566. Should I put them in order? Probably. T is approximately 1.333. T is approximately 2.469. And T is approximately 2.627. Okay, so those are my approximate values. An alternative method, or they abound. Another method we could use is you could graph v of t, v of x. You have to use x as your variable when you're graphing a function. And then graph 1, and then graph -1. And now you can see the intersection point, and I think that's extremely useful. And you do menu 814 for me, menu 813 possibly for you if you have a CX instead of a CX2. There, click. The thing I hate about this, it puts them like all right on top of each other. Sometimes you can like zoom box and get like a good window that'll like make them farther from each other. Like there, that was pretty good. And click and hold and drag. So there you can see them. I think that's pretty nice. Another option, just throwing all the options at you. This is the one I'm trying to avoid. Absolute value of v of x. Okay, so now I only need to graph 1 because this is the graph of speed. Now I'm going to try to get the intersection points. Let me zoom first. Let's zoom box first so that it's not trying to find more than it needs to. Menu 814. This is either going to work or not. Ooh, okay. That worked really smoothly. Now the final thing that I'm going to try to do on this part of the problem is, what are the other options? Particle change direction, speed, particle increase. Okay, So I'm going to do this. You know what? I'm going to do the other parts of the question, then I'll come back. We've already found it. All right, so I'm going to go back to the notes. I just like don't want to crash in the middle of the video. I don't mind crashing at the end, but it's like it's pretty much a video killer, you know? So let's see. Write an expression involving an integral that gives the position s of t. Use the expression to find the particle's position at 2, or the position of the particle at 2. So this is going to be where you started plus the integral of velocity, right? So it's going to be you start here, and then we're going to do the integral from 0 to t of v of dummy variable. So this is position s of t is where we start, which turned out to be 3, plus the integral from 0 to t of v of, I'm going to use x, v of x dx. So then s of 2, that's going to be an approximation. I will get that on the calculator, but let's find all times at which the particle changes direction, justify your answer. Okay, so we need to know when v of t equals 0. So we'll get those values. And then I'm gonna like just start answering. So the particle changes direction at t. And then I'm gonna just say, because I know that it changes, the particle changes direction when velocity changes sign. So I'm gonna say because v of t has a sign change at that value, those values, I don't know which to write yet, so I'm gonna not write anything. Actually, thinking of it, I remember the velocity from, I'm gonna say at those values. Okay, let's use a calculator. Is the speed increasing or decreasing at t equals 1? So I'm gonna need to find, let's not use the calculator. For speed increasing or decreasing, I'm gonna find v of 1. I'm gonna find, I'm gonna say a of t. So let's say a of 1 equals v prime of 1, and we'll get that. And if they have the same sign, speed is increasing. If they have opposite signs, speed is decreasing. All right, now let's do some calculator work. So I need to find s of 2. I need to find when the velocity equals 0, and I need to find a ton of stuff. So let's do that. Good question though. I like it. I like every part of it. All right, so calculator. Let's define s of t. S of t is going to be 2 plus the integral from 0 to t of v of x dx. So s of 2, let's put a decimal there, 1.900. Oof. I put the zeros. I like to go 3 decimals no matter what. We need to know when v of t is 0, so we could do solve v of t equals 0 for t. We could and probably should limit this. Let's just see what we get. All right, there's only the 2 values. Does v of t change sign there? Better to have a graph, right? So doc for graph. I know it's already in here somewhere. There it is. Let's change our window because we only care about 0 to 3. So let's go -0.5 to 3.5. I always like to like pad it a little bit just in case. I'm gonna add 0, and then I'm gonna do menu 814. Click here, click here. Okay, so the t values are definitely. This is when v of t equals 0. T is approximately 0.911. T is approximately 2.559. Okay, so particle does change direction at those values, 0.911, and t is approximately 2.559. And we already have the reason because v of t changes sign. Excellent. From here, I can actually tell. I'm going to do it anyway, but I can tell from the graph because let's just trace. Menu 5, graph trace. Trace until 1. V of 1 is definitely negative, and then also v prime of 1 is definitely negative also because v is decreasing, which means its derivative is negative, which means acceleration is negative. So I'm going to hold on and write this. Let's write this. 2, 4, 8. So from the graph, you can get the value of the derivative. I just never do. So menu, analyze graph, dy dx, graph, click, and then position is at 1. I just type 1. Negative 1.301. So negative 1.301. In fact, if you're in my class, this might be the first time you've ever even seen that feature of the calculator because I never use it. You can get derivatives from the graph. I just don't do it. And also that was really weird, right? Like it was like position and then it put a point. Like what are you doing? Like why is it doing that? And it doesn't tell you what it is. Like I feel that it's very unclear what you have done there. But what we did was we found v of 1. We got this. Then we found menu, forward, derivative at a point. The variable is actually t. The value is 1, and v of t. And I'll get that. So that is not the answer that I got before. Why is that? Negative 2. It's like almost twice negative. What is v of t? Is that right? Oh, I have no idea. 2t, what did it do? Oh, it factored t out. Okay, yeah. So what gives? Derivative. Okay, let me try this. So this is, I thought this would be the derivative at 1. Right, dy, yeah, let me delete that. Let me try it one more time. Menu, option 6. Dy dx, right? And then the graph. This is the graph of velocity. And I want it at 1. What is that? Let me graph, so I don't know what's happening there. Let me graph the derivative of v of x with respect to x. And then let me plug in, no, let me find, I'm just gonna trace, right? Because on this graph, if I trace to 1, negative 2 point, oof, what is happening there? I don't have an explanation for that. I have to think about that. It's not a trig thing, right? Because there's no trig involved. This is actually negative 2.693. I don't know. Never use that dy dx thing. I have no idea. I don't know what's going on. Why is that wrong? I don't know because I never use it. So never use that. Just do it on the calculator page, more accurate, or graph the derivative and get it there, I guess. I don't know. Is that going to happen at another point? This is like immaterial to doing the problem, but like let's do menu 6. Dy dx should be the slope. Click. Let's do it at 3, right? I'm just picking a random thing. So at 3, 40.63. Let me trace this to 3. Ew, what did I do? Menu 5, enter, trace to 3. 40.63. What am I doing wrong? I don't know. But man, now I feel like you can't trust anything. Let me get the coordinates of this. At 1. I don't know if it's rounded, like a weird rounding thing. Whatever. Never use dy dx on the graph, I guess. I don't know what else to tell you. If you're watching this and you understand what's happening, and you can put it in the comments to explain it to me, hopefully I'll remember what the issue is when I read your comment, but like, I don't want to make a video like 10 additional minutes while I explore that issue. Confident though that these are the values, I'm going to say, since v of 1 and a of 1 have the same sign, speed is increasing at t equals 1. All right, and that is the entire problem. So I'm going to stop the video here. I will come back and I will finish this page in the next one. Maybe I'll think about that derivative thing in the interim. I kind of doubt it. I will see you there.